Day 5 notes is on parallel lines cut by a transversal. Most of you should have seen this concept back in middle school, but we're going to go through and review this today and talk about ways that we can solve different kinds of problems involving these angles. So we're going to start out with a definition on parallel lines, and by definition, parallel lines are two lines that never intersect. So one of our lines that we can see in the picture here is line GH, and the other line that we see in our picture is line IJ. You can see I'm using the line symbols when I write them down. And when we write mathematically that they're parallel to each other, the symbol we use is a symbol that looks like two parallel lines. So I would indicate with this particular notation that these two lines are parallel using that mathematical notation. In my picture, we color parallel lines by putting little arrows on them to say, hey, these are both going the same way forever. If you have two parallel lines that are cut by a transversal, and a transversal is just any other line that passes through two or more given lines, which is what we have here, there are certain types of angles that are formed. So these are my two parallel lines, and I'll just put a T on this line that is the transversal. And you can see that what happens is the transversal creates basically two intersections with those parallel lines. The first intersection is the grouping of angles that you see here. The other intersection is the grouping of angles that you see here. So with those angles, with that grouping of the angles, we want to particularly in this case find where the alternate interior angles are, because alternate interior angles in this picture will be congruent to each other. Alternate means sort of opposite sides, and interior means in between the parallel lines. So the space that's in here is where your interior of the parallel lines is. Alternate means alternating sides of the transversal. So in this scenario, my alternate interior angles would be angle 4 and angle 6. They're both inside the parallel lines, but they're on alternating sides and locations of the transversal. And what we know is when we identify them, they are congruent to each other. My other set of alternate interior angles are going to be 3 and 5. They are on alternating sides of the transversal and locations, and they will be congruent to each other as well. Your job is going to be able to find these alternate interior angles and know that their measures are equal. In the second THM, which stands for the word theorem, which as far as you're concerned is really just a rule in math, we have a second set of angles that we want to make sure that you can find. Again, we have parallel lines and we have this transversal that cuts through them, and there's 8 angles that are formed. This time though, we are looking for what we call the corresponding angles. Corresponding means same position, the angles that match up. And once we recognize where they are, then we can say that they are going to be congruent to each other. So remember, the transversal intersects the first parallel line and then the second one. When the transversal goes along and intersects the first parallel line, angles 1 through 4 are formed. Those are the angles here. And then it goes along and intersects the second parallel line, and angles 4 through 8 are formed. So in this scenario, we have to find the ones that are in the corresponding location. Angle 1, which is in the upper left of the intersection, corresponds to angle 5 because it's also in the upper left. So angle 1 and angle 5 are identified as corresponding angles, and we're going to say that they're congruent to each other. And we're going to apply that same idea through the rest of the angles that are here. Angle 2 is in the upper right. Angle 6 is in the upper right. So angles 2 and 6 will be congruent to each other. And I'm just going to work my way through using these same ideas. Angle 3, lower right of the intersection. Angle 7, lower right of the intersection. So they will be congruent to each other. And then, of course, you can probably see the last set of corresponding angles. Angle 4 and angle 8, lower left and lower left. So angle 4 will be congruent to angle 8. And like I said, your job is going to be to identify the matching pairs of angles, these, and know that they're congruent to each other. Another pair of angles that we have to make sure that you're able to identify when you have parallel lines are what we call alternate exterior angles. Exterior meaning they have to fall outside of the parallel lines on alternating sides of the transversal. So when I'm looking, let's say, at angle 1 that's in the upper left, it corresponds, I shouldn't probably say corresponds, its pair for an alternate exterior angle is in the lower right. So they're exterior angles on alternating sides of the transversal, and they will be congruent to each other. My other pair of alternate exterior angles are going to be angle 2, which is in the upper right, and angle 8, which is in the lower left, alternating sides of the transversal outside the parallel lines. When you flip your paper over, they have given you a picture with some questions in it that they'd like you to answer. So they're telling you in this picture that the line they have labeled as L and the line that they have labeled as M are parallel to each other, and they want us to answer the questions that go with this. So it says, what kind of line is line N? They're missing the L in the word line, but it's line N. And what we know about line N is that it is a transversal. That's a vocabulary type question. They say in number 2, what kind of angles are 3 and 6? This goes back to your definitions. Angles 3 and 6 are interior angles, and they're on alternating sides of the transversal, so they are alternate interior angles. What kind of angles are 2 and 6 now, they're asking us? So 2 and 6, that's this and this. What I notice is that at the intersections, they are both in the upper right-hand corner of the 4 angles that make that intersection. So those are called corresponding angles, same corresponding position. They ask me about angles 1 and 8. I notice that those both fall outside the parallel lines. So those are exterior angles on alternating sides of the transversal. So I'm going to call them alternate exterior angles. Angle 1 is in the upper left. Angle 8 is in the lower right. They ask me about angles 3 and 7. So I'm going to highlight angles 3 and 7 here. So angle 3 and angle 7, those are corresponding angles, both in the lower left at each intersection. 6 and 7 is going to take us back a day. Angle 6 and angle 7, those are angles that are opposite each other on intersecting lines. Those are what we refer to as vertical angles. Number 7, what kind of angles are 5 and 7? 5 and 7, 5 and 7 basically sit on this straight line. So we would refer to them as either a linear pair of angles, or we could say that they're supplementary. And then they ask us also about angles 3 and 4. And when I'm looking at angles 3 and 4, that's these two. Angles 3 and 4 are the same kind of angles. They're either a linear pair, or you can refer to them as being supplementary. So there's a lot of vocabulary that we're throwing along in here. You want to make sure that you are able to answer those questions. In number 9, they're telling us that lines L and M are parallel, and they want us to find all the missing angles. When this scenario happens, essentially, all the angles in this picture are either equal to this 100-degree angle, as this vertical angle to it is, and this corresponding angle to it is, and this alternate exterior angle to the given 100 is, or our other possibility is that the other angles all have to be whatever the supplement to that 100 is, which is 80, vertical angle to that 80, alternate interior to that 80, vertical angle to that 80. So when we have a picture with two parallel lines cut by a transversal, one of two things turns out to be true. They are either equal to each other or they're supplements to each other, and that's one of the things that you want to keep in mind. Now, I have a little shortcut that I like to use on this, and I'll show you that now. We'll probably talk about it again later, but I'll show that to you now. And my little shortcut is if you have two parallel lines cut by a transversal, and you label all the angles AB, AB, all the way around clockwise, always starting in the same place, whatever the angles are that you're looking at, this will help you determine whether they're equal or supplementary. Anytime the two angles you're looking at both have A's on them, means that they're both equal. Anytime the two angles you're looking at both have B's on them, mean that they're equal. If by chance you have one A angle and one B angle, they're going to add up to 180. So if we use the little AB pattern over here in question number 10, if we filled in the AB, this is A, B, A, B, A, B, A, B, and I see that I'm looking at two angles that both have A's on them. A's are equal. Anything that's an A, all the other A's are equal to it. Then what that means is my x plus 60 will be equal to my 2x minus 10. They really are hoping that you have a little bit more knowledge than that, but that is definitely a short, quick way to get the right answer. Technically speaking, these two angles are corresponding angles, and corresponding angles are congruent, which is why we're setting them equal. So when I go through and solve this, I find out that x is equal to 70, which is part of what I have to do, but I also have to take this 70 and substitute it back in. 70 plus 60, 130. 70 times 2, 140 minus 10, 130. This is also 130 because it's a vertical. This is also 130 because it's a vertical. And then I also have some other angles in here that I have not yet filled in, and it says find the measures of all angles. These two angles here and here are supplements. They have to add to 180, so that'll be 50 and 50 and 50 and 50. Only two different angle measures can occur in your picture. Every angle in this picture is either an A angle that's measured as 130 or a B angle that's measured as 50.